Welcome to Easy Driver, the most reliable source of automotive information on YouTube. Please like, share, comment and subscribe. In this video we explore how rollback mechanisms protect autonomous features in Japanese cars in 2026. Autonomous feature rollback safety validation for Japanese cars in 2026. What happens when an over-the-air update makes a car less safe? In 2026, Japanese cars with Level 2 and Level 3 systems will update often, and sometimes they need to step back to a safer version. That step back is a rollback. The goal is simple: protect people, honor rules, and keep trust. This video explains what rollback means, the 2026 rules in Japan, and a clear engineering playbook teams can use to do it right. What is autonomous feature rollback, and when to use it in Japan in 2026? Plain definition with real-world examples. Rollback means reverting an autonomous or driver assist feature to a prior software version after a safety or performance issue appears. It keeps the feature, only rolls it back to a version that behaved better on the road. Two simple examples. Highway lane centering works fine on open roads, but a new release drifts in certain tunnels on the Shuto Expressway. Data shows higher lateral deviation and more driver takeovers in those segments. The automaker rolls back lane centering to the prior build that held lane better in tunnels. Automatic emergency braking, AEB, becomes too sensitive in heavy rain in Kyushu. False hard braking spikes at night during downpours. The automaker rolls back the AEB perception stack to a version with fewer false positives. Rollback is not a safety recall. A recall pulls cars in for repair or turns off a feature entirely. Rollback is part of a safe OTA strategy, used to reduce risk quickly while the team fixes the issue. Clear triggers that justify a rollback. Triggers should be simple and measurable, set before launch, and reviewed with safety teams. Examples include spike in driver takeovers per 1,000 kilometers. Increase in false braking events per 1,000 kilometers. Lane keeping deviation above a set limit, such as 0.3 meters sustained for 2 seconds. Sensor fault rates above baseline, such as radar dropouts or camera miscalibration flags. Repeated user reports tied to the same software build ID and similar scenarios. Agree on thresholds early, then use them to act fast. How an OTA rollback works on Japanese cars. The flow is straightforward. Detect the issue through fleet data, customer reports, or dealer feedback. Pause further rollout of the problem build. Approve rollback through a safety and compliance gate. Push the prior version to affected vehicles. Verify success with metrics and driver feedback. Japan aligns with UNECE rules for software updates, so cars need secure update paths, clear driver notices, and full records of what changed and why. Vehicles should display an update message, log the version change, and confirm the install. Benefits and risks to weigh before rolling back. Benefits include fast risk reduction for the fleet. Less exposure to unsafe behavior. Restored stability while long-term fixes are built. Risks include loss of recent fixes bundled in the new build. Possible mismatch between rolled back modules and current dependencies. Confused drivers if behavior shifts again without notice. A strong validation plan controls these risks with compatibility checks, clear messages, and disciplined testing. 2026 Safety Validation Checklist for Rollbacks in Japan. Know the rules. MLIT, UNECE R156 and R155, ISO standards. Teams must align rollback with key frameworks. MLIT guidance for advanced driver assistance and autonomous functions in Japan. UNECE R156, which governs software update processes, approvals, and records, including rollback. UNECE R155, which sets cybersecurity management requirements across the vehicle lifecycle. ISO 26262 for functional safety of road vehicles. ISO 21448, SOTIF, for safe behavior in scenarios without faults, where performance limits matter. ISO 24089 for software update engineering, including verification and documentation. Rollback needs approvals, risk assessment, traceability, and full documentation. Treat it as a safety action with a paper trail, not just a quick push. Pre-rollback validation that keeps people safe. Before rolling back, verify the prior version is still safe today. Confirm the older build is compatible with current hardware, sensor calibrations, and maps. Check dependencies across perception, planning, and HMI modules to avoid version drift. Run targeted simulation and regression tests that reproduce the failure scenarios, such as tunnel lighting or heavy rain glare. Update the safety case and record results in the change control system. Set rollout gates, such as pilot fleet size, geography, and time of day limits. Document a hazard analysis and risk assessment, HARA, that compares risk before and after rollback. This keeps the fix fast and focused, without creating new hazards. Post-rollback checks, sign-off, and audit trail. That wraps up our discussion on rollback fundamentals. Stay tuned for Part 2. Please comment, like, share, and subscribe for more automotive information like this. Thank you for watching.